this next section, we're going to look at finding the distance between 2 points on a graph. Now to do that, there's something called the distance formula, and I don't like it, so we're not going to use it. Instead, we are going to make triangles because everybody loves a good triangle. So I just took these 2 points that formed a straight line, and then I created a triangle, one that goes straight across the x horizontally and one that goes straight up and down on the y vertically. And what I'm going to do is figure out how long each of those sides are on that triangle. So here I start at -3 and I go 3 to the 0, and then I go 5 more. So I go 3 and 5, this side is a length of 8. And over here on my little right triangle, it is a right triangle, because it forms a right angle, one's going straight across, one's going straight up and down. This has a length of 1. And if you remember from earlier, when you have a right triangle and you know 2 sides, you can use Pythagorean theorem to find the third. So we don't know what that side is, but we're going to find out. Let's call it x. So Pythagorean theorem says take the 2 shorter sides, 1, square it, plus 8 square it equals our third side, our hypotenuse, squared, so x squared. 1 squared is 1, 8 times 8 is 64, equals x squared. And if we add those together, we get 65 for x squared. We don't want x squared, we want x, we want the distance. So to unsquare something, we square root it, leaving us with just x over here. And on this side, the square root of 65. Now, how does it want us to present these? It doesn't actually say in this case, but down below you'll see it says leave answers in simplified radical form when necessary. So when we see something like square root of 65, we might say, can that be broken down, or is that in its simplest, most broken down form? Well, I know that 65 is divisible by 5, so if we were to make a factor tree out of this, you can do that in your head or in your calculator. 65 divided by 5 will end up being 13, and neither 5 nor 13 will break down. Now, since neither of those 2 numbers breaks down and they're not forming any pairs, there is nothing we can actually do to simplify this any farther. So we will go back to our answer of simply square root of 65, and that is equal to x. That is the distance between this point right here and this point right here. So that is what we are trying to find, the distance between the points. If you were to look at this example here, I'm going to have you do this one on your own, but you would draw the triangle, something like that. You could also draw it up here, that would be acceptable as well. You'd find the distance of this just by counting the boxes, and you would then use Pythagorean theorem to figure out the length of this side right here and get it into its simplified radical form. This one will probably break down into a simpler root, so be aware that this one you will need to break down. Now let's go down below where we don't have a picture anymore, we just have points. Let's do a couple of these examples. The distance between these points. If you remember when we did the one above, we found the distance across and the distance up and down. So the distance across is how far apart the x coordinate is of this point and this point, how far apart the x's are. And the distance up and down are how far apart the y's are. So if we go back to this problem here, the distance between these x's is some number, and the distance between these y's is some number, and those are the 2 sides of your triangle. The distance between 7 and -3, if you imagine a number line here with 0 right here, -3 is back here and 7 is out here. So you would have to go 3 forward to get to 0 and then 7 more to get to 7. So 3 plus 7 is actually a distance of 10. So 3 and -7 are 10 apart. By the same logic, -8 and +6, if this is -8 and this is +6, you again have to go through 0. So you have to go 8 to get to 0, 6 more to get to 6. So you're going to be traveling a distance of 14. So let's use Pythagorean theorem now with those 2 short sides. 10 squared plus 14 squared equals our distance, or we can call that x or d, whatever you feel like, squared. 10 squared is 100, plus 14 squared is something you probably want to use a calculator for, which I can never remember. 196, still equal to x squared. Now you have 296 is x squared. And then you need to square root both sides to get x alone. Now if you're thinking, oh, let's make a nice simple tree out of 296, not so much. But we know it's an even number, so let's just start a divide by 2 fest and see how it goes. So put 296 in my calculator and divide it by 2, and I get 148. From there, well, that's even again, so let's just divide it by 2 again. 74. And now it's starting to get a little more reasonable. Still even, so let's divide it by 2 again. And we get 37. 37, I'm not sure is divisible by anything. I think it's a prime number, but if we try a few numbers, we'll find that it is in fact a prime number. There's nothing we can do. I see a pair of 2's, and that's it. So I still have the 2 and the 37 left under the root. This pair of 2's does come out front, leaving me with 2 to the times the square root of 2 times 37, which actually is going to be this one that it came from, 74. So our distance, our x, between these points is 2 root 74. That is the simplest radical form. Let's go ahead and do one more example of something a little bit weird. Number 32. We need to find the distance between the x's to get one side of our right triangle, distance between the y's to get the other. Between -3 and -3, well, they're the same. That's a distance of 0 apart. Distance between 1 and 2, well, 1 and 2 are 1 apart from each other. So if I were to draw this picture, it would look a little funny because it would just be a straight line up with a distance of 1. I could use the Pythagorean theorem still, and you can see what happens. 0 squared plus 1 squared equals x squared. Well, 0 squared is 0, 1 squared is 1, and 0 plus 1 is 1. And when I square root both sides, well, the square root of 1 is 1. So my distance, x, equals 1. These points are 1 apart. And you could have predicted that, because if it's a straight up and down line and they're 1 apart on that up and down line, well, they're 1 apart. Try a few more of these examples. Remember to find distance between your x's, distance between your y's, Pythagorean theorem, and then break down that root at the end to get it to its simplified radical form.